Chapter 9 questions. If the purpose of the hypothesis test is to establish that a population parameter is equal to or not equal to a specific value, then the equality statement is always assigned to the null hypothesis. Right, so there's your answer there. Let's talk about what happens here. A hypothesis test is going to have two parts to it. There is a null hypothesis. It's written with an H with a little zero. And there is an alternative hypothesis, sometimes written with a little a, sometimes with a little 1 there. So a hypothesis test always has two parts to it. The first part, the null hypothesis, always has some kind of equation, equality in it. So for example, it might be that a mean that we write with the mu is equal to a certain value. Maybe it's equal to 15. Then the alternative hypothesis is going to include everything else. That would be a not equal to 15. So this would be one example. The equality statement is always assigned to the null hypothesis. It doesn't have to be an equal to. It might be that the mean of the population is greater than or equal to 15, but it has the equality. In this case, the alternative hypothesis would be everything else, would be less than 15. Notice no equality with that one. Could also be written as the mean of the population is less than or equal to 15. Again, notice the equality sign with the null hypothesis. The alternative is that the mean might be everything greater than 15. So the equality statement is always goes with the null hypothesis. The null hypothesis is the assumed value. Null is the assumed value. Alternative is we're trying to show something besides what is assumed. Is an alternative. Is an alternative. To the assumption. Alright, so again, the null hypothesis always has the, and again, hypothesis just means our guess, our estimate. The null hypothesis will always have an equality statement equal to, greater than or equal to, or less than or equal to. The alternative hypothesis will always have some other type, not equal to, less than, or greater than. Good enough. So this next example highlights this. A professor would like to test the hypothesis that the average number of minutes that a student needs to complete a statistics exam is equal to 45 minutes. So the correct hypothesis statement would be, since the equal to 45 minutes has the equality symbol, then that has to be the null hypothesis. So that's got to be either here with the null, here with the null, or here with the null. And the alternative, or the H1, has to be everything else. So if one is equal to, the other has to be not equal to. And so A is going to be gone, and D is going to be gone. So the two pieces have to include everything, equal to and not equal to. And so your answer here is going to be B. Null hypothesis that the mu, or mean, is 45, equal to 45. Alternative hypothesis, H1, that the mu is not equal to 45. So what we do with a hypothesis test is we perform some statistical test. And if the probability, and we assume that the null hypothesis is true. So we always assume that H0, the null hypothesis, is true. We perform a test statistically, and that test involves a probability. So we gather some data and we find the mean or the proportion or the standard deviation of that data. And then we look at the probability of getting that result if the null hypothesis is true. We collect data. And that's a sample. And we ask, what is the probability of obtaining these results if the null hypothesis is true? If the probability is very low, we reject the null hypothesis. So what we're going to do is we're going to collect some data, and we're going to find the mean of that data. We're going to find some proportion within that data. We're going to find a standard deviation of that data. And if the probability of obtaining those results is so far away from what we assume to be true in the null hypothesis, then we're going to reject the null hypothesis. So with every statistical test, there's two outcomes. And the two outcomes are that we either reject the null hypothesis or we fail to reject. We can never confirm either the null or the alternative, but we reject the null hypothesis or we fail to reject the null hypothesis. And with both of those, there are potential errors. Maybe the data that you collected was not as accurate as it could be, was not an accurate reflection of the population of all the data out there. You just happened to get a bad or unrepresentative set of data. In that case, you make an error when you reject the null hypothesis. So you could get a type 1 error when you reject. That means you reject it, but it's true. Reject H0 when it is true. And with the second type, if you fail to reject, that means that your data did not give you a value so far away from the null hypothesis. So you fail to reject the null hypothesis. This is a type 2 error. You fail to reject when in fact when H null is false. All right? So these are the two types of errors that you can make with a statistical test. We're trying to make some kind of a guess about what all the data, the population data is. But we can't find all the population data. All we can do is to obtain a well-designed sample. And when we look at the results from that sample, we're either going to say that the value we obtained is so far away from what we assumed it to be that we're going to reject our assumptions, or the value we found was not so far away from what we assumed, and therefore we fail to reject our assumed value. So when we reject, there's a potential that we make a mistake, and that is a type 1 error. You rejected when it was actually true, and that's because you just happened to collect some data that was not representative of the population. The second type of error, type 2, is that you got a value that was not so far away from what you assumed it to be, and so you failed to reject. You said the null hypothesis appears to be fine, we're not going to get rid of it, but in fact it turns out that it is false, and it's just that the data that you collected, again, was not representative of the population. So that's why the answer here is 8. So if the professor wants to test the hypothesis that the average number of minutes that a student needs to complete a statistics exam is equal to 45 minutes. So a type 1 error would occur if the professor concludes that the average time is. So type 1 error means he rejected. So he concludes that the average exam time is not equal to 45 minutes, but in reality, the average time was equal to 45 minutes. So you rejected the null when in fact it was true. With this next question, we have the flip side of that. So a professor would like to test the hypothesis that the average number of minutes that a student needs to complete a statistics exam is equal to 45 minutes. A type 2 error would occur if the professor concludes that the average mean exam time is what? So a type 2 error, again, goes with failing to reject. So reject, H naught or H null, that is potentially leads to a type 1 error. When we fail to reject, then that potentially leads to a type 2 error. So type 1 can only happen when you reject the null hypothesis. Type 2 only happens when you fail to reject. So the professor concludes if he's trying to test that it's equal to, then we've rejected, we failed to reject that. So he concludes that the average time is equal to 45 minutes. However, in reality, it's not equal to 45 minutes, and so your answer is D. Right? So he concludes no change from the assumed value of 45 minutes based on the data that he collects. However, in reality, there is a difference, and it's not equal to. He failed to reject the null hypothesis, and he made a type 2 error. A golfer claims that his average golf score at the golf course he plays regularly is less than. Notice the less than here. The less than doesn't have an equal to, and so that has to be the alternative hypothesis. And so the null hypothesis will be everything else. We'll have the greater than or equal to. Remember, the null hypothesis has to have equality. And the alternative hypothesis is either greater than, less than, or not equal to.